Now we were simulating the stage with the transient rotor stage model. So you go open up in the below there, you'll be seeing the Cfx load solver or launcher. So again, you'll see the 4 icon here. Click Cfx Pre. Open up the Cfx Pre, maximize, and then we will open our case, our result file, right? So you will open the initial underscore 001 result file .res. Click open. So you load this one in the Cfx Pre, and we will save our file, save case file as a new name. You will name this one as Axial file, Axial.cfx is a new case file because now we are simulating the stage with the transient rotostator model. Click Save. Now you're going to modify the physical definition. So go to Tools, and we select Turbo Mode. So in the Turbo Mode, we will change the basic setting here. So you go to make sure you are selecting the Axial turbine. Yeah? So now we are going to use the transient model, transient. So total time will be 2.214 exponential minus 4, or E in the software is means 10 power or something, 10 power negative 4. And times total time is 2.2 e power 4. We break into 10. We break into 10 steps, 10 time steps. So you take this time divided by 10, you'll get 2.214 e negative 5 second. Okay. Then click next. So here you will be seeing component definition. Yes, we're still using these two. So click next. Physics definition here as display. Here we do not change anything. Physics definition, fluid ideal gas. However, for the interface here, we need to change to transient rotostator. This one, transient rotostator, and click next. So there will be a warning sign come out. Just click yes. So for the interface definition, we're still seeing the tree. Click next. Then the boundary, you can double check again by selecting. You see it will highlight for you. We do not change anything here. Just click next. Then our operation here, we will using general mode. Then after that, click finish. After that, we're going to set up the output control. So where is output control? You go to ribbon here. This one, output control. Left click. You go to output control. So we need to click the transition result. Click this one. Transient results. In the transient results here, in the blank here, you just need to add a name here. So add new item. And then we're going to use transient result 1. Transient result 1, click OK. So click transient result 1, you need to do some setting. So under transient result 1, you go to option, change the standard to selected variable. Okay. And then the output variable here, output variable list here, you need to change to, there's a 3 dot here, just click here. you need to select pressure. After you click this one, this window will go up, and you need to select multiple selection here. The first one, you go and select pressure, and then the next one, you're going to look at velocity. So let's look for velocity. So here, so hold down your hold down your control key keyboard on your keyboard, control key, and then hold your control key, and then left click. You're going to select pressure and velocity at the moment. And then one more is velocity in the standard flame. Hold down the control key and left click, and then click OK. So inside here, output variable list here, you'll be seeing pressure, velocity in the standard flame. Right? So make sure you have all this on your computer. And then for output frequency here, output frequency option, we're going to change this one to time interval. This one, time interval. So time interval, you're going to set as 2.124 10 power negative 5. In this case, we use E to represent the 10 power something. Right? Our interval is this value because we are using 10 steps. Each step is divided by 10 just now. Right? You take 2.24 10 power of negative 4 second divided by 10, you get this value. And click OK. So after that, we're going to modify our execution control. So go to the top ribbon here, click execution control. So execution control, you need to change the output file here. You go to run definition. Your input file, you need to change, open this one. You need to change the new name called axial.df. Okay, axial.df. Click save. So make sure this one is axial.df. And then the rest is look fine for me. You're going to using serial run mode. And we'll click OK. So we have done, and then after that, we're going to run the calculation. So go to the ribbon here, go to the SM button, define run. So again, you'll get a warning sign here. Don't worry, because we're going to solve this question later on, because the software do not have any input yet. We're going to input, do the setting later. Just click yes. Okay, now when you come to the Cfx Folder Manager, so the pre here, this one, you can save your file already. You can save the simulation. Just click Save Case and close Cfx Pre for Axial. Close this one. And you go to the Cfx Folder Manager that opened for you. Make sure you are using the axial.df file in the window here. Right, so the rest look fine for me. If you want for higher precision, just click double precision. We are using serial processing, and just click run. Okay. Hold on here. Let me see. Okay, so for CFX using transient, we need to do something under initial value here, because just now the warning is give us some warning, so we need to input this initial value. Okay, so click initial value, select initial specification. So under this specification value, select this one. Right, make sure this one selected. And then under the file name here, we're going to import file. So go to file name here, open a folder, go to the directory, and then open the Excel initial 001.result. Click this one, click open. So the file name, the initial input, we're going to use this file, result file. Then click, and then we're going to use mesh form. Mesh form. We're going to select solver input file here, right? Solver input file. And then click start run. This process is going to take about 4 to 5 minutes to solve the solution. So as you can see here, the solver manager is saying that you see is running, and then there's some activity on the output file here. So this process is going to take you about 4 to 5 minutes. Okay. So you can again, you can fast forward 4 to 5 minutes ahead just to catch up the next steps. Yeah. So this one is going to take you 4 to 5 minutes. Okay, so the simulation finished normally. There's no error. So at this stage, you already have the result already. So select this one, post process results. and you can shut off this Folder Manager. Click OK. Next, the computer will automatic open up the turbo pose for you. So make sure these two are selected. Click OK. You load the file for you. Okay. Then after that, we're going to initializing the turbo pose. So we go to turbo. So you ask you whether you want to initialize or not. Automatic initialize for you? Yes. Okay. So you can click this one, component 1 and 2. So click this one, you see, you can double click. So you see all the parameter setting here. Double click this one. Okay. So for R2, this one. Okay. Then you click turbo again. All right. Then you click outline. Okay, what else? Next one, we click the surface of the constant span there. So what you do, you go to the tree here. Plots, you go to blades. Double click blades to blades. You will see detail blades to blade plot, domain, all domain. And you're going to look half of the span there, at the middle of the span, 0.5. And just click apply. You will click apply. So you will see that this is the pressure contour for the plate at the half of the span there. So you can see that you need to capture this plate to plate preview and discuss about what have you observed. Okay, what is the maximum value of pressure? Where is it? And then what is the minimum? And so on. Yeah. So discuss about this observation. You can also view using multiple turbo ports. So we go to the plots here. You click 3D view, double click 3D view there, and then turbo view. You click initialization. So you go to initialization. There is button below the window here, single view and 3 view. You click 3 view. The view over here will give you 3 view. If you click single view, you will see the individual view. So click 3 view, capture this view and put in your report. So what does all this mean? It means that left hand side, this one is a 3 view of your simulation. Top right, this one is blade to blade, and this one is the meridional view. Okay, as you can see the title here, meridional view for this one. Okay. All right, now back to the single view. So you can change the view. If you drop down this one, you can change accordingly. Okay. All right. On the next one, we're going to create a turbo surface for our presentation. So how you create a turbo surface at the mid span, at the middle of this system. So go ahead and go to the top here, insert, location, and we're going to use turbo surface, this one. So it will ask you to insert the name. So we'll use the default name. All right, click OK. And you go to the geometry here. We will look at half span, so 0.5 there. And under the color, click color. So color mode here, we will choose variable. Variable means the color will change according to the value of the pressure, for example. Variable that we're looking for is pressure. And you can define the range here, okay? So we are going to user specify our range for our presentation. Minimum, we have negative 10,000. Maximum will be negative 7,000. Okay, so we will specify these two pressure range in our simulation for our presentation. Then you just click apply. So you will see the range is from negative 10,000 Pascal to maximum 7,000. Okay, so you can see the here, and you can rotate the file also. And you need to discuss, you need to capture these results, and then discuss about what have you observed. Okay, what have you observed? Where is the maximum pressure? Where is the minimum pressure? And so on. You need to zoom in and zoom out to have a further better resolution or better observation. Okay, capture this one and discuss about these results. The next one, we're going to set up instant transformation for our 3D simulation later on, a 3D animation. So you're going to set up instancing transformation. So in the turbo tree here, we're going to click go to turbo and then go to 3D view, double click 3D view. And in the 3D view, and then go to the graphic instancing here. Graphic instancing form for domain, you select R1. So you're going to copy R1 for 6 times. So increase this number to 6. Okay. So as you can see, this is the rotating part. This is not moving stator. This is the rotation blade R1. So you're going to copy this one 6 set. So copy 6. Then you click apply. So you're going to see this one copy 6, 1, 2, 3, 4, 5, 6. You repeat the same for the stator. Go to the global instancing here. Create S1s for your stator. Also copy 6 times. Apply. So you're going to have 6 stator there. Okay. Then you go to outline and fit the thing. So you can see the result is repeating 6 times. Okay. Discuss about this observation. As you can see, you rotate. You can see how's the component connected. Okay. So this one is rotating. This one is theta. Okay. Discuss about the maximum temperature inside the system. You can label the position A, B, C, D, and then you discuss. All right. Capture these results and put in your report. You can rotate, you can zoom in, and discuss about the results. All right. Next, we're going to animate the movement. We're going to save a video file. You don't need to submit the video file in the assignment. You just need to learn the skill to capture the animation. So we go to the time here. There's a time selector here. Click time selector. So time selector, what you're seeing here is at the time at the final, means the the blade move from below to up. So what you need to do is click the 0 here, double click. Okay, you click the file here and then click apply. Okay, 0, click apply. So it will load to its original position. Okay, then we close this one. You can go to here and turn off the wireframe if you want. Just uncheck, but I like the 3D view, so I keep the wireframe on. Okay, just to have an illustration of what's happening. All right, and we are ready for animation. So the animation, during animation, the blades will move up. Okay, or you rotate to the left, the animation will move to the right, to the left. So as you can see, the blade will move up later on. Okay, so you click the animation button here, animation. So in the animation, you select type. We're going to use keyframe animation. Then click new. So we're going to start from keyframe number 1, 1 to 10, 1 to 9. So make sure you are seeing number 9. Press enter here. Just to see the number 9 is here. So we're going to capture frame 1 until frame 9. Okay. Then we're going to open the time selector again, this one. Select the final, this one. Click apply. Okay. Then you go to this one. You need to add a new frame 2. So click new. So frame number 2 will start from 11. There will be 11 frame. A total of 11 frame, 9 frame intermediate plus 2 keyframe. So total have 11. Okay, you have actually you are taking 11 photo. Okay, 11 photo from here. Okay. Then after that, we're going to animation here. So we're going to save the movie. All right. Go to the option here. So option will be open up. So what we need to do is that we're going to use the transient case to time value. Time value. You can use time step also, but we prefer time value interpolation. Okay. And we will click OK. And then after that, we will save movie. Click this one. And it will save in the folder name as Axial.001. You can change this name if you want. Right? You can go here and change the name if you want. All right. And the format, you can save in a lot of format. You can save in JPEG, not JPEG, MPEG, AVI, or MPEG-1. I save in MPEG-1. Yeah? Then after that, I will go to here. I'll move the frame to the starting point, or I can move this slide to frame 1. Okay. So as you can see, the object moves down to the origin location. Okay, make sure you start with the frame 1. And then you play with the animation. You can close this time frame and you can start seeing the animation. Click when you start playing, you will start recording in the folder. Click play. frame number 2, 3, 4, and so on. So you can see the object is moving up. So the software is capturing photo by photo, and then they stitch them up, become a video file. It's like watching a cartoon, yeah? So you can play this video again, or you can go to the folder here. As you can see, is inside my ANSYS roto here. So you can see the Excel file is here. So you can view this video file in the very fast time. So this is the animation for the pressure on the turbo surface here. Okay, this is the animation that you recorded. All right, you can close this one and save the file if you want. All right. So with this, I end the recording.